on the same line like this. So this is the two representation of this chair form. Now when we look at this chair form and we draw the hydrogen atoms on this, so it acquires approximately 109 degree, and thus these are the hydrogen atoms. Here we have to remember that on these the hydrogen atoms must be placed in such a way that it should appear as a tetrahedral center, and so let us draw with hydrogen, and therefore we get to have this particular form. Now we have this. So put the hydrogens on this. So hydrogen, since this is pointing upward, so place hydrogen on this. This is pointing downward, place hydrogen in downward direction. Here it is upward, so place hydrogen. Downward now, so it is downward. Here it is downward, so it is. So all these hydrogens are, all these 6 hydrogens are called axial hydrogens. So these are axial hydrogens. So they are axial hydrogens, and the remaining hydrogens would be shown like this. It is here, this is here, this is here, this is here, this is here, and this is here. So these hydrogens, yellow hydrogens, yellow colored, hydrogen atoms shown are equatorial. Equatorial hydrogens. So these are equatorial hydrogens. So this is how we represent a chair form. Now basis this, so the angle is, here the angle is approximately equal to 109.5 degree. So this is 109.5 degree is the angle present. So we can, this is not exactly 109, but it is 109.5 degree. Similarly, the another form that we come across for this cyclohexane is the boat form, which is again similar to this one. Boat form. In this case, it is exactly appearing like a boat where the hydrogens are shown like this. So you can easily say these are axial hydrogens, and there would be another equatorial hydrogens. So we have again axial and equatorial hydrogens. So these two are the important form of cyclohexane. In between there are many other forms do exist, like half chair and the twisted boat forms. So let us compare the stability of these two forms. So if you compare this boat form with its counterpart, like its chair form, so we observe that in this case these two hydrogens and here it is, so these two hydrogen and these two hydrogens, so the same hydrogen is present here and here. So in this case there is more repulsion in comparison to this, therefore this form is supposed to be more stable than the boat form. If we have to analyze, and then we can also draw its Newman projection formula, and then we can compare their stability. So we can again say that out of these two forms, this form is more stable. So we can say chair is more stable than the boat form. Now the next question comes, out of these two in cyclohexanes, how do you identify cis and trans form? So identification of